Now let's talk more about outliers. We've already talked about them a bit. We've seen how box plots can show outliers in a different way from histograms. We're now going to start talking about how we would actually determine if we have outliers in a data set. So just as review, again, outliers will show up differently in different types of graphical displays. Here again is the box plot we looked at a little bit earlier, and you can see down here we have some outlying values, some values that are distinct and different from the majority of the data values in the data set. And we have the same data displayed here with the histogram. Clearly these values are outliers, but they don't immediately pop up as outliers in the histogram. Again, we don't see any gaps that would indicate that certain values are falling a bit further away from the distribution than other values. So how is it exactly that we know these values are outliers and can then plot them differently in a box plot? So that's what we're going to start talking about next. There are actually some formulas you can use to determine if you have outliers in a data set. So if you're ever not sure, you have a value, you think, this is a little bit higher or lower than most of my other values, I'm not quite sure exactly if it's an outlier, however, there is this formula that you can apply, and the formula essentially determines how far the value is from the middle of the distribution, and if it falls a certain distance away from the middle, it's considered an outlier. So how do we determine this? Well, the very first thing we want to do, again, is figure out our interquartile range. So that would be quartile 3 minus quartile 1, and that gives us the range of the middle 50% of the data. Now once you have that interquartile range, you simply multiply it by 1.5. So 1.5 times the IQR. So again, we start by finding the IQR, then we multiply 1.5 times the IQR. Now if we have what are called high outliers, meaning values that are larger than many other values in the data set or unusually large, those values would be larger than 1.5 times IQR plus Q3. So you'd figure this out, and then you'd add that number to Q3. And anything that is larger than that, larger than whatever you get here, that would be considered an outlier. Low outliers would be outliers on the lower end of the distribution toward the smaller values in the distribution. So with that, again, we figure out the 1.5 times the IQR, but this time we subtract that value from quartile 1. And anything that falls beyond this, lower than this value, would be considered an outlier. So these two numbers that you end up computing are meant to give you this range, and anything that falls outside of that range would be considered an outlier. So let's actually see how this works, going back to some data that we've already looked at. Here again is data set A, and let me just move this out of the way. So data set A, again, we can see our 5-number summary. So what I would do, first of all, again, figure out the interquartile range. Figure out Q3 minus Q1. In this case, that's 33 minus 1, which equals 32. So then what you want to do is you want to figure out 1.5 times the IQR. And I kind of left that out here in what you're going to see following this. So let me write it up here. So 1.5 times the IQR would be 1.5 times 32, and that's 48. So we figure out this number. What do we do now? Well, if we want to know if we have any low outliers, we take this number, 48, and we subtract it from Q1. So 1 minus 1.5 times 32, that would give us, again, 48. That ends up yielding negative 47. So we would look at our data set and we would want to know, do we have any values that are less than negative 47? And obviously we don't. Now again, I'm not seeing the full data set up here. I'm only seeing a 5-number summary, but the minimum in my data set is negative 20. So obviously I would have nothing that's less than negative 47. So I have no low outliers in this case. In terms of high outliers, again, we figure out 1.5 times the IQR. We add that to quartile 3. We then end up with 33 plus 48, that's going to give us 81. And obviously our maximum is 67, so we would have no high outliers. Now here I'm just trying to illustrate this by comparing these numbers to the 5-number summary. Obviously, if let's say if our minimum was much lower than -47, we'd want to go back to the data set and then see, is the minimum the only outlier, or are there other outliers in the data set? So there could be multiple outliers on the low end or on the high end. But in this case, with this particular data set, we know that we have no low outliers and no high outliers. So this is how you apply the 1.5 times IQR rule. So we call this the 1.5 times the IQR rule. It's not discussed in your textbook, so for that reason, it's very important to look very carefully at the discussion of this here in the lecture. It is something we'll ask you to apply, so be prepared to use this rule, perhaps in a homework assignment or on a lab activity or in an assessment. If we ask you if you have an outlier in the data set, we expect you to apply this rule to determine for certain if any values are outliers. Now I want to give you some practice. So we've learned a lot now, lots of different tools, lots of different values that we can compute, lots of different ways we can summarize a data set, and I want you to be able to practice this a little bit. So here's a data set. So you might want to pause this, write down the values, or hopefully you've printed this out and you have these values in front of you. So here we have 29 students, and we asked them to report, or we have 29 students, 29 students, so n equals 29. And we asked them to report on their daily time online in minutes. How many minutes do they spend online on average each day? And so here are the values that we got. So here's what we would like you to do. So again, I'd like you to pause this and try to work through this yourself, and then come back and compare your answers to what I'm going to show you, just as a way of testing yourself to see if you can do it. And please ignore this part. So this is an artifact of when I do a similar exercise in the lecture hall. If you are working with another student, though, you might turn to that student and try to work through it together. Perhaps you're watching this video with one of your peers. But if not, on your own, I would like you to try to figure out all of these things. Find the 5-number summary, determine if you have any outliers, so think about what we just did and how you can use that rule to determine if you have outliers. And then think about what your box plot will look like. So once you have the 5-number summary, try to draw a rough sketch of that box plot. And in addition to thinking about what the box plot's going to look like, think about what shape that distribution is going to have. So once you get your box plot, once you see how the numbers compare to each other within the 5-number summary, do you think you're going to have skewness? If so, in what direction? Or do you think it looks like a more symmetric type of distribution? So again, pause, try to work through this to the best of your ability, and then come back and see my way of working through it. Okay. So hopefully you have a few numbers now, and we can see if your numbers match my numbers. If they don't, again, always check my calculations. It's possible I made an error, and if I did, I want to figure it out right away. And I apologize if I made an error and didn't spot it ahead of time. But if your numbers are not quite matching mine and you're not sure why, please ask questions. Let us know so we can try to help you. I used some color coding in these next few slides just to highlight where things are. So I started by finding the median. Now again, we have an odd number of data values here. We had 29 data values. And so I went right to that middle value. And remember, if you're not quite sure where the middle value is, you could use that formula. So n plus 1 divided by 2. That's not going to give you the actual number of the median, but that'll give you the position of the median in the data set. So I had 29 plus 1 over 2. That's 30 over 2. That equals 15. So I know if I order things from smallest to largest and go right to the 15th position, that's going to be my median. And an important thing here, now since we have this odd number of values and the median is right in the middle, remember we want to kind of lightly cross it out because we want to know that now when we find our quartiles, we don't want to use that 47 in our calculations. So I'm now trying to find quartile 1, and the median again was 47. So quartile 1 would be the median of the first half of my data. That ends up being the average of 30 and 32, or 31. Quartile 3, again, we find our median. Here it is. And then quartile 3 would be the median of the second half of the data, everything above the overall median. That, again, would be the average of two values, 77 and 78, or 77.5. So hopefully so far you got those quartiles, you got the median. The rest of our 5-number summary would just be the minimum and the maximum, so those are pretty easy to figure out. And you might have even started by figuring out the minimum and maximum, because you can easily do that. You can easily see what starts the data set, what ends the data set. So here are our numbers, our 5-number summary. So that was part of what I asked you to do. And then I asked you to think about whether you have any outliers and think about what the box plot is going to look like. So do we have any outliers? So what is the first thing you would do? Find the IQR. That would be 77.5 minus 31, which gives us 46.5. And then we find 1.5 times the IQR. And that's going to give us about 69.75. And then what do? Well, we take this number, we add it to quartile 3, and we subtract it from quartile 1 in order to see if there are any values that maybe fall outside of this new range that we're going to get. So quartile 1 minus 69.75 equals 31 minus 69.75, and that's going to equal negative 38.75. And then quartile 3 plus 69.75. That's going to equal 147.25. Okay, so obviously we have nothing that's less than negative 38.75, and since we're looking at time, we couldn't have a negative value. So we have no low outliers. In terms of high outliers, I'm going to say yes, we have high outliers. How many do we have? Well, I know that I have at least one because the maximum's 151. So I have at least one high outlier. Let's go back. My next lowest is 135, so that would not be an outlier because that's not larger than 147.25. So we have one high outlier. So yes, let's say a high outlier. And that high outlier is 151. So this time we do have outliers. Very quickly, hopefully you took some time to create a box plot. So if you just made the box plot based on the 5-number summary, it would look like this. Remember, we have our minimum, quartile 1, the median, quartile 3, and then the maximum. The median is closer to quartile 1 than it is to quartile 3. We have a large tail here going toward the larger values. So I would say we have a distribution that's skewed right. Hopefully that's what you were thinking about as well when you were looking at your box plot. The median's much closer to the minimum than it is to the maximum. So again, we have 50% of our data scrunched down here, and then the other 50% is more spread out toward the larger values. So that's what's giving us that skewness to the right. Now, again, we know that we have an outlier. So quickly, we can modify our box plot to include that outlier. So what I did is I just took, rather than having this line extend to the maximum, I have it extend to the next lowest value that's not an outlier. So here's our outlier of 151. So a modified box plot would be one where you actually show the outliers. Okay, I'm going to wrap this up now, and we'll come back and try to get through the rest of our lecture in one quick video. Thanks, everyone.